Probability concepts. Here are the sections that we will go over. First, a brief introduction. Investment decisions require an evaluation of risk. And just to give you a simple example, when you purchase a stock, obviously you are concerned about what will happen to the stock price. When you purchase the stock, let's say it is $50, you are concerned about the risk of the stock price going down. Now, in order to try and understand the risk, what you might think of is the probability that the stock price will go down below $40, the probability that the stock price will be between 40 and 50, and so on. So clearly then, probability is an important tool which can help us evaluate risk. In this reading, we will explore probability-related concepts which are most relevant for investment managers. Probability, expected value, and variance. We need to first understand a few basic definitions. A random variable is an uncertain quantity or number. So if you buy a stock today for $50, at the end of the month, the stock price will have a certain price. We can think of that price as a random variable because we don't know what that price will be. An event is a single outcome or a set of outcomes. So we can define an event that the stock price is going to be less than 50. So this is a particular event. This event consists of a set of outcomes. And what are those outcomes? Those outcomes are stock price being equal to say 49.99, 49.98 and so on. So all possible outcomes such that the stock price is less than 50 represent this event. We might have another event which says that the stock price is going to be greater than or equal to 50. So what we have done here is defined two possible events, and note that each event is essentially a set of different outcomes. Mutually exclusive events. What I have done here is defined mutually exclusive events. What that means is that if event 1 occurs, then event 2 cannot occur. So clearly we cannot have a situation where the stock price is both less than 50 and greater than or equal to 50. So these two events, event 1 and event 2, are mutually exclusive. Exhaustive events means that between these two events, all possibilities are covered. And notice that the two events shown here are also exhaustive. The probability of a given event has to be between 0 and 1. So if I say the stock price today is 50, then the probability that the stock price will end up being less than 50 at the end of the period has to be between 0 and 1. If I am fairly sure this will happen, then the probability will be close to 1. If I am fairly sure that this will not happen, then the probability will be close to 0. But it is not possible to have a probability that is greater than 1 or a probability that is less than 0. The sum of the probabilities of mutually exclusive events must be equal to 1. So if we know that these two events are mutually exclusive and exhaustive, and we know that the probability of the stock price being less than 50 is equal to 0.3, then the probability of the stock price being greater than 50 has to be 0.7. And note that the sum of these two probabilities has to be equal to 1 because events E1 and E2 are mutually exclusive and exhaustive. We'll now look at different ways of estimating probability. One method is called empirical probability. This is where we calculate probability using past data. Let us say that we are looking at a particular stock market where there are 700 stocks, and of these 700 stocks, 350 pay dividends. Now, if the question is the following, what is the probability that a stock picked at random from this population will be a dividend paying stock? And if we say that the answer is 350 over 700, which is equal to 0.5, then 0.5 is a empirical probability because we have arrived at this probability through a analysis of the data. A priori probability. This is calculated by using formal reasoning and inspection. Just to give you another simple example, let us say that the stock price is currently $50 and we say that the probability of the stock price going up is 50% and the stock price going down or staying the same is also 50%. And we use the reasoning that given the current stock price, there is an equal chance of the stock going up or down. Now, this is based on reasoning. The reasoning might not be correct, but at least there is an attempt at some formal reasoning. Probability arrived at using this method is called a priori probability. Subjective probability. This method is less formal and involves personal judgment. Let us say that I have a high opinion of the new CEO of company X, and I say that because I believe the CEO is good, the probability that the stock price will go up is 0.8. This probability is based on my personal judgment about the quality of the CEO, and we would say that this is a subjective probability. Here is a simple practice problem given what you've just learnt. The correct answer is B. Probability stated as odds. Let's say that we have an event E and the probability of that event is equal to 1/3. Let's say the event is that the stock price will go down and we know the probability. How can we express this probability as odds for E? What are the odds that the stock price will go down? This is the formula that will allow us to translate the probability into odds. Probability of the event 1/3 divided by 1 minus the probability of the event. So 1 minus 1/3 is 2/3. 1/3 divided by 2/3 is simply equal to 1 over 2. So the odds are 1 over 2, and the way we write odds is by saying 1 to 2. So the odds of the stock going down are 1 to 2. In other words, a probability of 1/3 is exactly the same as odds of 1 to 2. These are two different ways of saying the exact same thing. If we can go from probability to odds, we should also be able to go from odds to probability. And this is how we do that. If the odds are expressed as A to B, now the first item here is A, the second is B. In our example, A is 1 and B is 2. The implied probability of the event, so PE, is equal to A, which is 1, divided by A plus B, which is 1 plus 2 in our example. So 1 plus 2, what we essentially have is 1/3, which is exactly what we started with. So it is a fairly straightforward and mechanical exercise to convert from probability to odds and from odds back to probability. The odds against an event are given by this expression. Notice this is simply the reciprocal of what we saw here, and that makes sense because to calculate the odds against E, instead of using PE, we use the expression 1 minus PE, which is essentially the probability of not E, and then in the denominator, instead of 1 minus PE, we do 1 minus PE, and that is simply PE. All you need to do is remember that if the odds for an event are given by this expression, the odds against are given by the reciprocal. And when you work backwards, the implied probability of not E, or the odds against E, are essentially B over A plus B. Let's see if you can do this simple problem now. The correct answer is A. We will now talk about conditional versus unconditional probability. Unconditional probability, PA, is the probability of an event regardless of other outcomes. So our event here is A. This might be the probability that a stock price goes up. So the event is stock price going up. The probability of that stock price going up regardless of any other events is called an unconditional probability. A conditional probability is written like this. So we might say, what is the probability that the stock price will go up assuming interest rates go down? So in this particular scenario, event A is that stock price goes up, and event B is that interest rates come down. So we might say that the probability that stock price goes up given that interest rates go down is equal to 0.6. This is a conditional probability because this probability is the probability of something happening, i.e. stock price going up, conditional on another event. The condition in probability terminology is expressed using this bar between two events. Joint probability and the multiplication rule. So let us first understand what we mean by joint probability. The probability that both A and B will occur is their joint probability. It is called PAB. So whenever you see AB without anything in between, that means we are talking about the joint probability of two events A and B. Continuing with my previous example, we might ask the question, what is the probability that both stock price goes up and interest rates come down? Remember, event A was stock price going up, event B was interest rates going down. So the probability that both A and B happen is probability of AB. That's how we express a joint probability. We can compute the joint probability using the multiplication rule, which is the first formula that you are going to learn. So the probability of both A and B happening is equal to the probability of A given B. This is the conditional probability of A. So the probability of A conditional on B happening multiplied by the probability of B. If you have this expression, then you can use simple algebra to compute the probability of A given B, so the conditional probability given a joint probability and the probability of B. So if you get a question on the exam where you are provided the conditional probability and the probability of B, you can then compute the joint probability. On the other hand, if you are given the joint probability and the probability of B, then you can compute the conditional probability. From this expression, I hope you can see that probability of AB can also be written as probability of B given A multiplied by the probability of A. Let us look at a simple example. So if the probability that interest rates will decrease, and I'm just calling that event D now, is equal to 40%, and the probability that the stock price will increase is written as PS, what is the probability that the stock price will increase And let's say that we are given that the probability stock price will increase given that interest rates decrease is 70%. This is a conditional probability. Now, the question is, what is the joint probability? The joint probability that the stock price will increase and interest rates will decrease. It is expressed like this, PSD, and we have learned through the multiplication rule that PSD is equal to P S given D times probability of D, which is 0.7 from here times 0.4 from here. So our answer is 0.28 or 28%. Next, we need to learn the addition rule for probabilities. The probability that A or B occurs or both occur is given by this expression. So A or B means A happening or B happening or both happening. This is equal to probability of A plus probability of B minus the joint probability. Again, take a simple example. You have two stocks, A and B, and you want to know what is the probability of A going up or B going up or both going up. If you are given that the probability that A increases, this is the unconditional probability of A going up, is equal to 0.5. The unconditional probability that stock B goes up is 0.7. And you are also given the joint probability that both stocks go up, which is 0.3. Then probability of A or B is computed using the addition rule, and we simply have 0.5 plus 0.7 minus 0.3, which is 0.9. See if you can do this question now. The correct answer is A. You need to use the addition rule, and when you use the addition rule, you should get 0.8. Independent and dependent events. First, let's talk about independent events. This is where the occurrence of one event does not influence the occurrence of the other. Take a simple example. Let's say that you have a particular stock in a country in Asia. So let's say we have a stock called 4G fertilizer, and you have another stock in the United States, different country, completely different industry. So you have these two stocks, a Microsoft stock and a 4G fertilizer stock. The performance of these two stocks is independent. So Asian markets open first. Let's say that you know that on a given day this stock has gone up. Knowing that the stock has gone up tells you nothing about what is going to happen to the Microsoft stock. If that is indeed the case, then we say that these two events, let's say this is event A of 4G fertilizer going up, this event is completely independent from event B, which is Microsoft stock going up. When two events A and B are independent, then the conditional probability, the probability of A going up given that B has gone up, is equal to probability of A, or equivalently, the probability that B goes up or Microsoft goes up given that 4G fertilizer has gone up is simply the probability that Microsoft will go up. In other words, knowing A or knowing the probability of A tells you nothing about the probability of B. What happens to the multiplication rule when we have independent events? Probability of AB, the joint probability, is simply equal to probability of A times the probability of B. And you can remember from before that in the formula that you saw earlier, we were using probability A given B. Since probability of A given B is simply probability of A when the events are independent, that's what we plug in here. And I will actually connect back to a problem that I'm sure you saw when you studied probability in high school, where if you flip two coins, what is the probability that you get heads on both coins? I'm sure you recognize that flipping two coins, these are two, let's say two events, and the two events are independent. So the probability of getting heads on the first coin is half. The probability of getting heads on the second coin is half. So the probability of getting heads and heads is simply half times half, which is 1/4. So that is an example of using the multiplication rule with independent events. To check your concept now, let's see if you can understand the addition rule for independent events. So if you recall, the addition rule is probability A or B, so that's probability of A happening or B happening or both happening, is equal to probability of A plus probability of B minus the probability of AB, i.e. minus the joint probability. Now, with independent events, the addition rule remains the same. So a lot of students get confused about this, but I just want to emphasize the fact that the addition rule doesn't change when you have independent events. Why? Because there is still a probability that both events will happen. Even though A and B are independent, it is still possible that both 4G fertilizer goes up and Microsoft goes up. So these are independent events, but the joint probability is most likely non-zero. Now let's take a look at dependent events, and very simplistically, if two events are not independent, then they are dependent. With dependent events, knowing the outcome of one event tells you something about the probability of the other. So the question is, what is the relationship between dependent events and conditional probability? Note here that a dependent event, when we say dependent events, we are talking about events. But here with conditional probability, we are talking about a probability. So we go back now to our multiplication rule. So probability of AB is equal to probability of A given B times the probability of B, or we can say that probability of A given B is equal to probability of AB divided by probability of B. So this is the expression that is connecting dependent events, A and B in this case, with conditional probability, where the overall expression is giving us the relationship between the joint probability and the conditional probability. So essentially, you need to make sure that you remember this formula, that you remember the formula for the addition rule, and you remember the fact that if events are independent, then the multiplication rule is impacted, but the addition rule is not. A quick practice question: if events A and B are mutually exclusive, then which of the following is true? The correct answer is C, because for mutually exclusive events, the joint probability AB is simply 0. If they are mutually exclusive, that means that you can't have A and B both happening. So our addition rule simplifies to this expression. Now let's take a look at the total probability rule. In investment analysis, we often formulate a set of mutually exclusive and exhaustive scenarios and then estimate the probability of a particular event. Before I get into this somewhat complicated looking terminology, I will just make a high-level remark, which is that the total probability rule enables us to state unconditional probabilities in terms of conditional probabilities. So let's say we have two scenarios. Scenario S is that interest rates go down, and non-S or not S or S complement is that interest rates do not go down. So that covers all other scenarios, interest rates remaining stable or interest rates going up. So between S and non-S or not S, we have two events that are mutually exclusive and exhaustive. According to the total probability rule, the probability of event A, let's say that is the probability of stock price going up, is equal to the probability of AS, which is the joint probability of stock price going up and interest rates going down, plus probability of stock price going up and interest rates not going down. Sometimes we express this not S as SC or S complement. S complement simply means not S. Now, this expression can be written as PA given S times PS. This is our multiplication rule, and this can be written like this, again using the multiplication rule. So, for a two scenario situation, the total probability rule is simply this: probability of stock price going up is equal to probability of stock price going up given that interest rates go down, multiplied by the probability of interest rates going down, plus the probability that the stock goes up given that interest rates do not go down, times the probability that interest rates do not go down. If we have more than two scenarios, then the same expression can be generalized. So notice that here we have A, S1, S2 up to Sn. S1 is the first scenario, second scenario, and so on. And then each one of these items can be expanded using the multiplication rule. And again, I'll go back to what I said earlier, which is that the total probability rule allows us to take conditional probabilities and use the conditional probabilities to arrive at an unconditional probability. We now change gears a little bit and talk about the expected value of a random variable. The probability weighted average of the possible outcomes of the random variable. The expected value of a random variable is essentially the probability weighted average of the possible outcomes of the random variable. So if you look at this expression, the random variable is x, and x1, x2 all the way to xn represent the different possible outcomes. By multiplying each outcome by the probability of that outcome and then adding up these numbers, we have the probability weighted average for the different possible outcomes of the random variable. This is better understood through an example. Say you are running a project and the cash flow for the upcoming year depends on the state of the economy. If the economy is good, then the cash flow will be 50. The probability of this scenario is 0.3. With average economy, probability 0.5, the cash flow is 40. Weak economy, probability 0.2, the cash flow is 20. So what is the expected value of the random variable? The random variable x is the cash flow. So what is the expected value of the cash flow? Clearly, the expected value should depend on these numbers, 50, 40, 20, and it should also depend on the probability. So what we do is simply say 0.3 into 50, and we come up with the number 0.5 into 40 and figure out what that is, 0.2 into 20, figure out what that is. And then when you add those three numbers, what you should get is a expected value of 39. The interpretation is that given these probabilities and these possible values for the random variable, the expected value is 39. Here is a practice problem for you just to ensure that you understand the concept that we just talked about. And here is the answer, it's B. Notice that we are simply taking each probability, multiplying by the random variable, and then adding all the expressions. Now let us look at the variance of a random variable. The variance is the expected value of the squared deviations from the random variable's expected value. The expected value is simply the probability weighted average. This is what we saw on the previous slide. So if we look at the same example and now try to calculate the variance and the standard deviation. Notice that we are looking for the expected value of the squared deviations from the expected value. The expected value of the random variable is 39. We've just calculated that. We then need to find the squared deviation from 39 and then find the expected value of those squared deviations. So here is what can be done. This is the squared deviation for the first cash flow. So one scenario is the cash flow is 50. The squared deviation would be 50 minus 39. 39 is the expected value of the random variable. 50 minus 39 squared is 121. Similarly, with a cash flow of 40, the squared deviation is 1. Here the squared deviation is 361. We then want to find the expected value of the squared deviations. To do that, we simply take each squared deviation, multiply by the probability, 0.3 over here, 0.5 and 0.2. This 36.3 is the squared deviation times the probability. When you add these three numbers, we essentially get 109. So 109 is the variance for these cash flows given the probabilities. Standard deviation is simply the square root of the variance. So our standard deviation is 10.44. You don't really need to memorize this formula, but this is effectively what we've done. This part over here is the squared deviation. So the deviation squared, and we are taking the expected value of the squared deviations. Or notice that the expected value is simply the probability weighted average. So that is what we are doing here. Whether or not you understand this expression, you need to be able to do these calculations and recognize the fact that the variance is giving us a measure of how spread out these cash flows are from the expected value of 39. A high variance means that the data is very spread out, so the project is more risky. A low variance means that the data is not too spread out, which means the project is relatively low risk. Alright, so let's see if you can solve this problem. Again, it is simply testing the concept that you just learned. And here is how you do the calculations. The answer you should come up with is 4.28. Next, we learn how to use the calculator for problems such as this. Same cash flow. And here are the keystrokes. This might seem a little intimidating, but that's because we've just given all the details. So you first get into data entry mode, then you clear the data registers. You then enter the first random variable value, which is 50. And then you need to somehow enter the fact that the probability is 0.3. The way you can think of this is, we are telling the calculator that for every 100 possible outcomes, 50 would happen 30 times. So this 0.3 is put in as 30%. What you'll see on the calculator is y01 is equal to 30. Then you enter 40 over here and 50, which is the 0.5 probability, and so on. Once you've entered all the numbers, you then go into statistics mode by doing second stat. Then you must hit the second set. So second set repeatedly until you see 1v. This stands for one variable. Even though you are entering x and y, but effectively it is the cash flow variable that you are after. You must see n equal to 100. If you see anything else, that means you made a data entry error, because all these numbers 30, 50, 20 must add up to 100. You hit the down arrow again, you will see the expected value, which is 39, and you have seen that before. Hit down arrow again, you will see the sample standard deviation. That's not what you are after, because this represents a population. So when you hit down arrow again, you will get the population standard deviation, which is 10.44, and that is what you calculated earlier. If you want the variance, then you can simply square this number. Now let's look at the total probability rule for expected value. Recall that the total probability rule enables us to state unconditional probabilities in terms of conditional probabilities. So these expressions you've seen before. This is the total probability where we just have two scenarios. This is the total probability for A, or the unconditional probability for A, where we have multiple scenarios. We can state expected value in terms of conditional expected values also. The expected value of a random variable x can be written as the expected value of x given s times the probability of s, plus the expected value of x given not s times the probability of not s. Look at the similarity between these two expressions. Here we are taking the expected value of x given event s. Here we are taking the probability of a given event given s. So then we multiply by the probability, which is the same thing over here, and hopefully you can also see the parallel between these expressions. And for a situation where you have more than one scenario, you can see the parallel between these two expressions. To highlight what we have seen, let's look at an example. What is the expected price of a stock at the end of the current period given the following information? The probability that interest rates will decline is 0.4. So interest rates going down has a probability of 0.4, which means that interest rates not going down, the other scenario, probability is 0.6. We are told that if interest rates go down, then there is a 0.75 probability that the stock price will be 100 versus a 0.25 probability that the stock price will be 90. And with the interest rates not down scenario, there is a 50-50 probability that the stock price would be either 80 or 70. So question is, what is the expected stock price given this information? And we can use the expression that we just saw. The first thing we do is figure out the expected value of the stock price given S. Let's say that the event S is that interest rates go down. So we are on this leg of our probability tree. So the expected value of X, which is a random variable, that's the price of the stock, given that the interest rates go down. The expected value of the stock price given that interest rates go down, so that's our event S. That means that we are over here. So what is the expected value of the stock price given that interest rates go down? We do that by saying 0.75 into 100 plus 0.25 into 90. So that is equal to 97.5. What if interest rates do not go down? That probability is 0.6. So the expected value of X given that interest rates do not go down, that is 0.5 into 80 plus 0.5 into 70. So this number is 75. So what now is the expected value of the stock price? That expected value will be 0.4 into 97.5 plus 0.6 into 75, which is equal to 39 plus 45, which is 84. So that is the expected value of the stock price. This problem could also have been solved by calculating the probability of each of these nodes. Point 3 is simply 0.4 into 0.75, 0.1 is 0.4 into 0.25, and so on. You could get the expected value of the stock price by saying 0.3 into 100 plus 0.1 into 90 plus 0.3 into 80 plus 0.3 into 70.